There's something hauntingly beautiful about the way ancient cave paintings seem to glow in the flickering light of a torch, lines and shapes etched into stone by hands that lived tens of thousands of years ago. These aren't just random doodles or simple hunting scenes. Look closer and you might notice something strange: spirals that resemble galaxies, dots arranged like constellations, and patterns that mirror the very fabric of reality as we understand it today. What if these primal artworks weren't just depictions of daily life but a coded message, a cosmic blueprint left behind by our ancestors? It's a thought that sends shivers down the spine, because the deeper we dig, the more it seems these ancient artists might have been onto something far bigger than we ever imagined. Fast forward to the modern era, where particle physicists peer into the subatomic world, uncovering laws that govern the universe: quarks, neutrinos, quantum entanglement, concepts so advanced they feel light years away from those crude cave drawings. And yet, here's the mind-bending twist: the same geometric patterns found in prehistoric art appear in the mathematical equations that describe the fundamental forces of nature. It's as if the universe has been whispering the same secrets across millennia, first through the hands of early humans, and now through the cold precision of science. Could it be that our ancestors, without telescopes or particle colliders, somehow tapped into a deeper understanding of reality? This isn't just a wild theory, it's a mystery that's gaining traction among archaeologists, physicists, and historians alike. From the caves of Lascaux to the equations of Einstein, there's a thread connecting the dawn of human creativity to the cutting edge of cosmic discovery. In this video, we'll unravel that thread, exploring how symbols from the Stone Age might hold keys to the universe's greatest puzzles. We'll examine the eerie similarities between ancient art and modern physics, dive into the rituals and beliefs that could have inspired these designs, and ask the provocative question: did early humans possess a kind of intuitive wisdom that science is only now catching up to? Buckle up, because what you're about to discover could change the way you see history, the cosmos, and even yourself. The moment early humans picked up charcoal or ochre to mark the walls of their caves, something extraordinary happened. It was the birth of symbolic thought, the spark that set us apart. These weren't mere scratches or idle doodles. The paintings at Lascaux, for instance, show bison and horses frozen in motion, their legs overlapping in a way that suggests an understanding of movement, almost like early animation. But look beyond the animals and you'll find something even more intriguing: dots, lines, and geometric shapes arranged in patterns that mirror the night sky. At Chauvet Pont d'Arc, a cave so ancient its art predates the last ice age, there's a chamber known as the Panel of the Lions, where claw marks and painted beasts seem to dance beneath a ceiling studded with what could be stars. What were these artists trying to convey? One theory suggests they weren't just drawing what they saw, they were mapping it. Some researchers point to the repetitive clusters of dots found in caves across Europe, noting how closely they align with the positions of constellations like Orion or the Pleiades. Others believe the spirals and labyrinthine designs might represent cosmic forces, the same swirling energies we now describe through quantum fields and string theory. It's as if these early humans, with no telescopes or mathematics, were instinctively grasping the rhythms of the universe. And here's where it gets even stranger. Modern physics tells us that at the smallest scales, reality is made up of vibrations, patterns within patterns. The same fractal-like designs we see in cave art, repeating, self-similar shapes, appear in the equations that describe subatomic particles. Could it be that these ancient artists, through ritual, trance, or sheer observation, tapped into a visual language that science is only now decoding? The caves might have been more than shelters. They could have been the first planetariums, sacred spaces where the cosmos was studied and revered. This isn't just about art or astronomy. It's about the very nature of human consciousness. When those first strokes of pigment touched stone, it marked a leap in how we perceive reality. We didn't just see the world, we began to interpret it, to find meaning in the chaos. And if these symbols really do hold echoes of universal truths, then perhaps the boundary between ancient intuition and modern science isn't as rigid as we think. Maybe, just maybe, the answers to some of physics' biggest mysteries have been hiding in plain sight, etched in torchlight, waiting for us to look up and notice. Spirals winding across cave walls like frozen whirlpools, these mesmerizing patterns appear in prehistoric art from France to Indonesia, carved by cultures separated by oceans and millennia. What's startling isn't just their prevalence, but how closely they mirror the fundamental forces modern physics struggles to explain. Take the double spiral in Newgrange, Ireland, a stone passage older than the pyramids. Its twisting arms resemble the mathematical curves of gravitational waves or the spin of entangled particles. Then there's the chamber of the spiral in Spain's La Palta cave, where concentric circles pulse outward like ripples from a quantum fluctuation. Could these be mere coincidences, or did ancient artists sense the cyclical nature of reality, the way galaxies rotate, particles oscillate, and energy perpetually transforms? Now consider the dots. In caves like El Castillo and Altamira, clusters of pigment dots form precise arrangements. Some anthropologists argue these match star formations, like the 7 dots aligning with the Pleiades, a constellation sacred to cultures worldwide. But here's where it gets eerie. Modern particle physics uses nearly identical dot patterns to map quark interactions in Feynman diagrams. Those same clustered dots appear in cave art dating back 40,000 years. It's as if our ancestors intuitively sketched the building blocks of matter long before microscopes revealed them. Animal figures add another layer to this cosmic cipher. At Lascaux, a painted bull's flank is marked with rows of dots resembling atomic orbitals, while horses seem to dissolve into starbursts of lines, an uncanny parallel to how quantum fields visualize particle collisions. Even the way these animals overlap, as if existing in multiple states at once, evokes the principle of superposition in quantum mechanics, the most compelling part. These symbols didn't exist in isolation. Many appear alongside handprints, human signatures pressed into the stone. Perhaps this was more than artistic expression. It might have been a profound attempt to say, we are here, and we are part of this vast, interconnected dance. From spirals encoding cosmic rhythms to dots mapping invisible forces, these caves may hold humanity's first scientific models, a bridge between the tactile world and the hidden dimensions that shape it. Imagine standing in the darkness of a cave, your only light a flickering flame, as the walls around you seem to pulse with hidden energy. Many researchers believe this was the world of ancient shamans, spiritual guides who ventured into altered states of consciousness, seeking visions beyond ordinary reality. These weren't just artists painting what they saw. They might have been explorers of the mind, mapping territories science is only now beginning to chart. Take the trance dances of the San people in southern Africa, where rhythmic movement and hyperventilation induce states of ecstasy. In these moments, shamans report seeing luminous grids, spirals, and tunnels, the same geometric patterns found in cave art across the globe. Known as entoptic phenomena, these visions arise from the brain's hardwired response to altered states. whether from rituals, fasting, or plant medicines. But here's the striking part: these shapes don't just stay in the mind. They appear on cave walls, etched with precision, as if the shamans were transcribing messages from another layer of reality. Now compare this to quantum physics. At the subatomic level, particles exist in probabilities rather than fixed states, a concept that defies everyday logic. Scientists rely on advanced mathematics and particle colliders to glimpse this hidden realm, yet shamans, through trance, might have accessed a similar understanding intuitively. The zigzags and wave-like patterns in cave art, for instance, bear an uncanny resemblance to quantum wave functions, which describe how particles behave as both matter and energy. Even the famed dancing sorcerer painting in Francis Toifrier's cave, a half-human, half-animal figure mid-movement, echoes the duality central to quantum theory, where particles exist in multiple states until observed. This isn't about mysticism replacing science. It's about parallel paths to truth. Indigenous cultures often describe reality as a web of interconnected energies, a concept mirrored in modern string theory's vibrating filaments. The hallucinogenic brew ayahuasca, used by Amazonian shamans, is said to reveal a universe alive with conscious energy, not unlike the quantum field where particles blink in and out of existence. Could these shared visions hint at a universal template, a deep structure of reality accessible through both trance and equations? The caves might have been more than canvases, they could have been portals. In cultures from Siberia to the Americas, shamans speak of descending into the earth to commune with spirits or ancestors, a journey eerily paralleled by physicists diving into particle accelerators to uncover the universe's blueprints. Both seek answers to the same eternal questions. What is the nature of existence? How are all things connected? Perhaps the most profound takeaway isn't that ancient people predicted quantum mechanics, but that they recognized a truth modern science is still grappling with, that reality is far stranger, far more interconnected than our senses suggest. The cave paintings aren't just art or ritual, they're fragments of a forgotten dialogue between humanity and the cosmos, a conversation we're only now relearning. The animals that dominate cave walls, bison, horses, lions, weren't just lifelike portraits of prey or predators. Look deeper, and their presence feels almost mythic, as if they carried meanings far beyond the hunt. Take the towering bison of Altamira, their massive bodies frozen in motion. To modern eyes, they might symbolize raw power, but what if their significance was cosmic? The bison's sheer gravitational presence, the way they seem to anchor the cave walls, mirrors the invisible pull of celestial bodies. In indigenous traditions, bison often represent abundance and the earth itself, suggesting ancient artists might have seen them as embodiments of planetary forces, their bulk echoing the weight of the universe. Then there are the horses, their slender legs stretched mid-gallop across the stone. Their speed isn't just artistic flair, it could reflect an intuitive grasp of light's velocity, a primal understanding of energy in motion. In Norse mythology, the sun itself was pulled by a chariot of horses, linking their movement to cosmic cycles. The way these painted horses dissolve into streaks of pigment, almost like motion blur, hints at an awareness of time's fluidity, a concept physics now quantifies as relativity. Lions add another layer to this symbolic language. In Shovit Cave, they're often depicted mid-roar, their jaws wide as if channeling raw energy. Could these be early representations of stellar forces, supernovas, or solar flares rendered in a form the human mind could grasp? Across cultures, lions symbolize solar power, from the Egyptian sun god Ra to the Mesopotamian lion-headed storms. The cave's shadowy recesses, illuminated only by firelight, might have felt like a theater of the cosmos, where flickering flames made the lion's eyes gleam like distant stars. Even the lesser-known creatures fit this cosmic puzzle. Birds painted with wings outstretched mirror the fractal branching of lightning or the paths of comets. Fish, their scales rendered in meticulous dots, could symbolize the quantization of energy, the idea that nature moves in discrete packets, a principle central to quantum theory. It's as if these artists were working with a vocabulary of symbols, each animal a shorthand for a fundamental force. What's truly remarkable is how these interpretations span continents and epochs. The same horse appears in French caves and Mongolian petroglyphs. The same lion prowls African rock art and Ice Age Europe. This consistency suggests a shared human intuition about the natural world's hidden rhythms, a language of symbols transcending time and space. Whether through ritual, observation, or altered states, our ancestors seem to have glimpsed a truth science now frames in equations, that the universe speaks in patterns, and we've been trying to translate them for millennia. The cave walls weren't just canvases, they were the first blackboards where humanity's earliest teachers sketched the laws of existence in strokes of ochre and charcoal. Those geometric patterns scrawled across cave walls, grids like woven baskets, zigzags like lightning frozen in stone, concentric circles pulsing outward like ripples in a pond. They might seem simple at first glance, but their simplicity is deceptive. These shapes repeat across continents and cultures, from the labyrinthine finger flutings in Australia's Cunalda Cave to the honeycomb grids in Spain's Cueva de la Pasiega. What's astonishing isn't just their prevalence, but how precisely they mirror the invisible scaffolding of reality as modern physics understands it. Take the humble grid. In caves, these intersecting lines often form backgrounds for animal figures or stand alone as abstract designs. To a physicist, though, they're uncannily familiar. Lattice models, the mathematical frameworks used to describe how particles interact in crystals or quantum fields, rely on nearly identical grids. Even string theory, which posits that the universe's fundamental building blocks are tiny vibrating strings, visualizes these vibrations as patterns unfolding across grid-like dimensions. Could those ancient artists have sensed the underlying structure of space itself, translating it into a visual language we're only now decoding? Then there are the zigzags. In caves like Pech Merle in France, they slash across walls like captured energy, reminiscent of the erratic paths of subatomic particles in a cloud chamber. Modern physics uses similar jagged lines, Feynman diagrams, to map how particles collide and transform. The parallels don't stop there. Indigenous cultures from the Americas to Africa associate zigzags with lightning, a primal force that early humans might have intuitively linked to the invisible energies governing the cosmos. But the most haunting patterns are the concentric circles. In Newgrange, Ireland, they spiral inward like portals. In the American Southwest, they radiate outward like shockwaves. These shapes aren't just artistic flourishes, they're mathematical echoes. The equations describing gravitational waves, ripples in space-time caused by colliding black holes, produce nearly identical waveforms. Even the way sound travels as concentric rings through air or water mirrors quantum field disturbances. It's as if these ancient artists were sketching the universe's heartbeat. The deeper mystery, these geometries often appear in caves alongside handprints, as if marking a human presence within the cosmic design. Perhaps that's the most profound insight of all. The realization that we're not just observers of these patterns, but participants. From the quantum foam to the galactic web, the same geometries repeat, suggesting a universe that speaks in shapes, and our ancestors, it seems, were fluent long before the rest of us even knew the language. Deep in the caves of Europe, where torchlight once flickered against walls adorned with animals and symbols, there's a growing suspicion that these ancient artists were doing far more than decorating. Hidden among the bison and handprints are clusters of dots, sweeping curves, and precise lines that might not be random at all. They could be the earliest star maps ever created. In places like Lascaux, the arrangement of dots above a painted bull's shoulder matches the constellation we now call Taurus, complete with the Pleiades star cluster. Another section of the cave shows a sweeping arc of dots that mirrors the path of the Milky Way, as it would have appeared over 15,000 years ago. It's as if these caves were more than shelters. They could have been the first observatories, where the night sky was studied and recorded with astonishing accuracy. But the evidence goes beyond just dots on a wall. At Spain's El Castillo cave, researchers discovered a series of red discs painted in a sequence that aligns with the phases of the moon. Over time, the discs grow larger and smaller in a rhythm that matches the lunar cycle, suggesting these early humans weren't just casually noting the sky, they were tracking it. Even more striking, some caves feature narrow shafts or openings that allow sunlight to penetrate only at specific times of the year, like the summer solstice. In one Romanian cave, a beam of light pierces the darkness on the winter solstice, illuminating a painted symbol that could represent rebirth or renewal, a celestial event encoded in stone. What's fascinating is how universal this practice seems. In North America, the ancestral Pueblones carved spirals into rock faces that align with solstice sunlight, while in Turkey, the world's oldest known temple, Göbekli Tepe, features pillars engraved with animals that may correspond to constellations. These cultures, separated by thousands of miles and years, all seem to share a common impulse: to translate the heavens into something tangible, something they could touch and revisit. The implications are profound. If these markings really are astronomical records, it means our ancestors possessed a sophisticated understanding of celestial mechanics long before written language or formal science. They noticed patterns in the chaos, the predictable return of seasons, the steady dance of stars, and turned those observations into a kind of proto-science. This wasn't just mythology, it was early astronomy, a way of making sense of the universe's rhythms and harnessing that knowledge for survival, ritual, or both. Perhaps the most humbling thought is this: without telescopes or calculators, these ancient stargazers mapped the cosmos using nothing but patience, keen eyes, and the walls of their caves. They may not have known why the stars moved as they did, but they recognized the patterns, and in doing so, they laid the foundation for everything that came after. The cave paintings aren't just art, they could be humanity's first scientific notebooks, filled with data we're only now beginning to decipher. And if that's true, then the story of our cosmic curiosity stretches back much, much further than we ever imagined. Quantum entanglement is one of the most baffling discoveries in modern physics, the eerie phenomenon where two particles, no matter how far apart, remain mysteriously linked. Change the state of one and its partner responds instantly, as if space and time don't apply to them. Einstein famously called it spooky action at a distance, a phrase that captures just how unsettling this invisible connection feels. Yet for all its strangeness, this idea of entanglement, of things being fundamentally intertwined, might not be so foreign to human thought. In fact, it could be one of the oldest ideas we've ever expressed. Look closely at cave paintings and you'll notice something curious. Animals, symbols, and handprints rarely exist in isolation. A bison might be surrounded by clusters of dots, its body intersecting with lines that stretch toward other creatures, as if everything is part of a single flowing tapestry. In the cave of the Trois Freres, a stag's antlers branch into zigzags that dissolve into the rock, merging with abstract shapes nearby. These aren't just artistic choices, they feel like visual echoes of entanglement, where boundaries blur and separate entities share an underlying unity. The parallels go deeper. Indigenous cultures worldwide describe reality as a web of relationships, where every element, animals, plants, even stones, is alive and interconnected. The Aboriginal concept of a dream time, for instance, speaks of a timeless dimension where all things are linked through ancestral energy. Similarly, quantum physics now tells us that at the most fundamental level, particles don't exist as isolated points, but as probabilities within a vast, vibrating field. The universe, it seems, is less a collection of objects and more a symphony of connections. Here's where it gets truly mind-bending. Many cave paintings were created in deep, lightless chambers, far from the entrances where people lived. Why venture into such darkness? Some researchers suggest these spaces were chosen precisely because they mimic the void, the featureless quantum vacuum where particles flicker in and out of existence. In that absolute blackness, with only torchlight to guide them, ancient artists might have experienced a heightened sense of unity with the cosmos, a state where the boundaries between self and world dissolved. The art they left behind could be snapshots of that perception, where every stroke acknowledges the invisible threads binding all things. This isn't to say Stone Age shamans understood quantum mechanics as we do today. But intuition operates differently from equations. Just as a musician might feel the harmony of a song before knowing the theory behind it, early humans could have sensed the interconnected nature of reality long before science confirmed it. The caves, with their echoing chambers and flickering shadows, may have been the first laboratories, places where humanity glimpsed, however dimly, that the universe is far more mysterious and woven together than it appears. And if that's true, then those ancient handprints on the walls aren't just signatures, they're reminders that we, too, are part of this entangled dance. Step into one of these ancient caves, and you'll notice something beyond the striking visuals. The way sound behaves here is unlike anything in the outside world. The walls curve and compress, turning whispers into booming echoes, footsteps into rhythmic pulses. Places like France's Rouffignac Cave or Spain's Cueva de la Palta aren't just silent galleries. They're natural resonating chambers where the slightest noise can ripple through the darkness like a wave. Archaeologists have discovered that many painted chambers coincide with spots where acoustics are most intense, narrow passages that amplify chanting, domed ceilings that bounce back voices in cascading layers. It's as if these spaces were chosen not just for their visibility, but for how they transformed sound into something almost tangible. Now, consider the rituals that might have unfolded here. Imagine a shaman's voice rising in the gloom, the cave's walls bending and stretching each syllable until it feels less like speech and more like a force of nature. Drums beaten in these chambers wouldn't just be heard, they'd be felt, their vibrations traveling through stone and bone alike. Some researchers suggest these sonic effects weren't accidental but intentional, a way to alter consciousness, to bridge the gap between the physical and the unseen. The repetitive echoes could have induced trance states, blurring the line between the self and the surrounding world, much like the rhythmic drumming used in modern shamanic practices. This isn't just speculative anthropology. Modern physics reveals that vibration isn't merely a phenomenon, it's the bedrock of reality itself. At the quantum level, particles aren't static objects but vibrating strings, their oscillations determining everything from mass to energy. The entire universe hums with frequencies we can't hear, from the spin of electrons to the gravitational waves rippling through space-time. Could ancient humans, immersed in caves that magnified every whisper and thrum, have sensed this deeper truth? Without equations or microscopes, they might have experienced vibration as a sacred force, the invisible thread weaving the world together. The evidence is etched into the art itself. Many cave paintings feature dots and lines arranged in rhythmic sequences, like visual representations of sound waves. In Portugal's Escaural cave, red ochre strokes curve and pulse in patterns that mirror the harmonics of chants recorded in similar spaces. Even the animals depicted often seem mid-movement, their bodies frozen in dynamic tension, as if capturing the moment a drumbeat hangs in the air. It's a haunting parallel to how physicists today use waveforms to describe particles. Both cultures, separated by millennia, translating vibration into visual language. Perhaps the most striking connection lies in the materials. Ochre, the pigment used in many cave paintings, isn't just colorful, it's dense with iron oxide, a mineral that resonates at frequencies similar to those of the human voice. When applied to certain cave walls, these paintings might have subtly altered the acoustics, turning the rock into a kind of primal speaker. Experiments in replicas of these caves show that singing near painted areas produces clearer, more resonant tones, as if the art itself was tuning the space. What emerges is a picture of caves as more than shelters or canvases. They were living instruments where sound, art, and belief intertwined. The people who gathered here thousands of years ago may not have known about quantum fields or string theory, but their experiences in these echoing chambers could have given them an intuitive grasp of vibration's power. In the flickering torchlight, with voices swelling around them, they might have felt deeply and viscerally what science now confirms, that the universe isn't silent. It sings, and in those sacred spaces, our ancestors might have heard its first notes. The holographic principle is one of the most radical ideas in modern physics, a theory so counterintuitive it bends the mind. It proposes that our three-dimensional universe, with all its depth and volume, might actually be a projection of information encoded on a distant two-dimensional surface, like a cosmic movie playing on an unimaginably vast screen. At first glance, this sounds like pure science fiction, but the math behind it is startlingly robust, emerging from the study of black holes and the nature of information itself. And here's where it gets even wilder. If the holographic principle holds true, then everything we perceive, stars, galaxies, even our own bodies, could be akin to shadows cast by a deeper, hidden reality. Now rewind tens of thousands of years to the caves. Those flat stone walls, meticulously decorated with ochre and charcoal, might have been more than just canvases. Think about it. Ancient artists were taking the vibrant, three-dimensional world around them, the galloping herds, the towering cliffs, the vast night sky, and compressing it into two-dimensional representations. A bison painted on a wall isn't just an image, it's a reduction of something complex into a simpler form, much like the holographic principle suggests the universe itself operates. Could these early humans have stumbled onto a symbolic truth about reality's nature without even realizing it? Consider the way cave paintings often layer images atop one another, creating palimpsests of overlapping figures. A single wall might show mammoths, handprints, and geometric signs all interwoven, as if multiple realities coexist in the same space. This mirrors the holographic idea that information isn't stored in isolated bits but is deeply interconnected, with every part containing traces of the whole. In some caves, like Argentina's Cueva de los Monos, handprints stretch across panels in repeating patterns, almost like pixels on a screen, a haunting echo of how the holographic universe might encode data in discrete, repeating units. The parallels don't stop there. Many indigenous cultures describe reality as an illusion or a dream, a concept that resonates eerily with the holographic principle's suggestion that our world is a kind of projection. The Aboriginal peoples of Australia, for instance, speak of the dreamtime as a foundational layer of existence, where the boundaries between objects blur and everything is part of a unified whole. Similarly, Hindu cosmology describes the universe as Maya, a grand illusion shimmering atop a deeper truth. These ancient philosophies, like the cave art itself, seem to hint at a reality where surfaces deceive and dimensions intertwine. What's truly mesmerizing is how this idea bridges the earliest human creativity with the cutting edge of physics. Those cave walls, once thought to be simple records of daily life, might instead be humanity's first intuitive grasp of a holographic cosmos, a flat surface whispering secrets about the universe's true shape. Whether by accident or insight, our ancestors may have been drawing not just animals, but the very fabric of existence, one stroke at a time. And if that's the case, then those ancient pigments on stone aren't just art. They're a mirror reflecting back a truth we're only now beginning to see. One of the most striking patterns in cave art isn't just what's painted, it's how often the same motifs reappear, layered over one another like echoes across time. In caves like Lascaux and Chauvet, animals are drawn again and again, their outlines overlapping in a way that suggests not just a single moment, but the passage of seasons, the ebb and flow of migrations. A herd of deer might be shown with antlers in various stages of growth, or horses painted with different coat patterns, as if capturing their transformations over months or years. These aren't static snapshots, they're dynamic records of cycles, the very rhythms that governed ancient lives. This fascination with repetition and return finds an eerie parallel in modern physics' most mind-bending theories. Take eternal inflation, the idea that our universe is just one bubble in an endless, frothing multiverse, where new universes constantly bud off from older ones in an infinite cycle. Or the concept of conformal cyclic cosmology, which proposes that the universe doesn't end with a bang or a whimper, but resets with each big bang, emerging from the remnants of the previous cycle. Time in these models isn't a straight line, it's a loop, a spiral, a wheel that turns without end. The caves seem to whisper a similar intuition. In Spain's El Castillo cave, a series of red discs painted in a sequence show gradual shifts in size and spacing, like phases of the moon waxing and waning. At Cresswell Crags in England, zigzag patterns carved into stone mimic the seasonal flooding of rivers, a visual record of nature's recurring pulse. Even the way these symbols are positioned deep within caves, far from daylight, hints at a deeper understanding. That time isn't just something observed, but something navigated, even ritualized. What's remarkable is how these ancient artists encoded cyclicality, not just in subject matter, but in technique. Many cave paintings were created over generations, with new layers added centuries apart, as if each artist was contributing to an unbroken chain of memory. In Indonesia's Sulawesi caves, handprints stenciled in ochre span thousands of years, their pigments blending into a chorus of voices across time. It's as if these communities sensed that their stories weren't isolated events, but part of a grander pattern, one that future generations would inherit and extend. Physics now offers a lens to reinterpret these patterns. Quantum mechanics reveals that particles can exist in superpositions, their states cycling through probabilities until observed. Cosmology suggests the arrow of time may be an illusion, with entropy and order locked in an eternal dance. The caves, in their own way, seem to have grasped this, that existence isn't a straight path but a tapestry of returns. Whether depicting the rebirth of spring or the endless spin of celestial bodies, these artists may have been the first to map time's true shape not as a river flowing forward, but as a wheel forever turning. Dots, they seem so simple, tiny marks of pigment pressed onto stone, scattered across cave walls from Europe to Australia, but their simplicity is deceptive. In places like El Castillo Cave in Spain or the rock shelters of Arnhem Land, these dots aren't random. They cluster in precise formations, sometimes aligned in rows, other times arranged in arcs or grids. At first glance, they might resemble stars or raindrops, but look closer, and something more profound emerges. These patterns mirror the way modern physics diagrams fundamental particles, discrete points of energy, the building blocks of reality itself. Consider the way these dots appear in cave art. In France's Pechmerle, a horse painted in black outlines is surrounded by a constellation of dots, as if the animal is emerging from a field of energy. In Indonesia's Ling Tedong, handprints are framed by dot clusters that ripple outward like waves. These aren't just decorative flourishes, they feel deliberate, almost mathematical. What's fascinating is how closely they resemble Feynman diagrams, the tools physicists use to map particle interactions. In those diagrams, dots represent quanta, the smallest possible units of energy, and lines trace their movements. It's as if ancient artists without the language of equations were sketching the same idea. That reality isn't smooth and continuous, but granular, made of countless tiny, interconnected points. This concept of granularity isn't just a modern revelation. Indigenous cultures worldwide have long described reality as a tapestry of interconnected energies. The Aboriginal peoples of Australia, for instance, speak of the land as a living grid of song lines, invisible pathways connecting sacred sites. Each site, like a dot on a vast map, pulses with meaning, part of a larger pattern. Similarly, in quantum physics, the universe isn't a blank canvas but a shimmering network of probabilities, where particles blink in and out of existence like dots on a cave wall. The parallels are uncanny, and they raise a tantalizing question. Were these early humans intuiting a truth that science would only formalize millennia later? Even the placement of these dots hints at deeper knowledge. In some caves, they're found in deep chambers far from natural light, suggesting their importance wasn't just aesthetic but ritualistic. Shamans might have used them as focal points for meditation or trance, their repetitive patterns inducing altered states where the boundaries between self and cosmos blurred. Modern neuroscience shows that repetitive visual stimuli like grids of dots can trigger brainwave patterns associated with transcendent experiences. It's possible these ancient artists weren't just depicting reality, but engaging with it, using dots as portals to perceive the universe's underlying fabric. The most compelling evidence lies in the dots' consistency. Across continents and epochs, they reappear in similar configurations, as if echoing a universal language. In the Americas, dot grids resemble the atomic lattices of crystals. In Africa, they mirror the fractal branching of lightning. This isn't just coincidence, it's a testament to humanity's shared intuition about the world's hidden architecture. Whether through ritual, observation, or sheer creativity, our ancestors seem to have grasped a truth we're still unraveling. That reality, at its core, is a dance of dots, a cosmic code waiting to be read. And those ancient markings on cave walls, they might be the first fragments of that code, left for us to decipher. From the winding caves of Europe to the sun-baked rock shelters of Australia, the same symbols appear again and again. Spirals that coil like galaxies, handprints pressed against stone as if reaching across time, clusters of dots mapping unseen constellations. These aren't isolated expressions but fragments of a shared language, one that spans continents and millennia. In the depths of France's Chauvet Cave, lions stalk the walls in ochre shadows, their forms echoing the Lion Man sculptures of Germany's Hohenstein Stadel, carved over 40,000 years ago. Meanwhile, in Australia's Kimberley region, the Wandjina figures, ancestral beings with halo-like heads stare out from rock faces with the same radiant presence as the sun gods painted in Spanish caves halfway across the world. The eerie consistency isn't just coincidence, it's a testament to something deeper, a universal human impulse to translate the cosmos into symbols. Take the spiral, for instance. In Ireland's Newgrange, it twists into the stone, a labyrinthine path leading inward. The same motif appears in the Americas, where ancestral pueblones carved it into desert cliffs, and in the Pacific, where Maori artists wove it into sacred tattoos. Spirals aren't just decorative, they're cosmic shorthand. Modern physics sees them in the spin of electrons, the vortices of black holes, even the double helix of DNA. Ancient cultures, separated by oceans, may have sensed this same pattern pulsing through nature, from the curl of fern fronds to the whirl of celestial bodies. Then there's the handprint. From the caves of Borneo to the canyons of Argentina, human hands press against rock, some stenciled in blown pigment, others pressed directly into clay. These aren't mere signatures, they're declarations of presence, a way of saying, I am here, part of this vast tapestry. In the Aboriginal traditions of Australia, handprints connect the living to the dreamtime, a timeless dimension where ancestors and landscapes intertwine. Similarly, in the caves of Patagonia, handprints cluster beneath painted guanacos, as if linking hunters to the herds they relied on, a visual echo of quantum entanglement, where observer and observed are inseparable. The most haunting parallels lie in the celestial symbols. In Africa's Tassili Naja, cave paintings depict figures with raised arms, surrounded by dots that mirror the Pleiades, the same star cluster venerated in Greek, Mayan, and Japanese myth. Native American petroglyphs in Choco Canyon chart solstice alignments with precision rivaling modern observatories, while in India's Bhimbetka rock shelters, crescent moons and sunbursts adorn walls older than agriculture. These recurring motifs suggest a shared celestial literacy, a primal understanding that the heavens were not just lights in the sky, but a mirror of earthly cycles, a clockwork of seasons and stories. What does this global tapestry tell us? It's not that ancient cultures communicated across impossible distances, but that they arrived at similar truths independently, guided by the same night sky, the same turning seasons, the same human brain wired to seek patterns. The caves were humanity's first classrooms, where the curriculum was written in starlight and stone. Whether through shamanic vision, meticulous observation, or sheer creative intuition, these early artists tapped into a reality deeper than geography, a recognition that the universe speaks in shapes, rhythms, and connections, and we've been listening far longer than we realized. The symbols on these walls aren't just art, they're the first paragraphs of a story we're still reading, one where every culture adds its own verse to the same eternal song. Dreams have always been a bridge between worlds, where the familiar twists into the surreal, where time bends, and the impossible feels tangible. For the artists who painted cave walls tens of thousands of years ago, dreams might have been more than just nightly wanderings of the mind. They could have been a source of revelation, a window into realms where animals spoke, stars danced, and the boundaries between the physical and the spiritual dissolved. Look closely at the caves of Lascaux or Altamira, and you'll notice something peculiar. The animals often appear superimposed, their bodies merging or overlapping as if they exist in multiple states at once. A bison might fade into the shape of a bear, or a horse's outline could dissolve into a swirl of dots, a visual echo of the way dreams blend and warp reality. This fluidity isn't just artistic license, it mirrors the very nature of quantum physics, where particles defy classical logic. In dreams, an object can be in two places at once, much like an electron existing in superposition until observed. Time can loop backward, parallel to quantum entanglement's defiance of spatial separation. The cave's most abstract symbols, zigzags that pulse like neural synapses, spirals that pull the viewer into their vortex, resemble the imagery reported in lucid dreams or shamanic visions. Modern neuroimaging reveals that during deep dreaming, the brain's visual cortex lights up with patterns strikingly similar to these ancient motifs. It's as if the cave walls became canvases for a shared dreamscape, where the artists transcribed visions that science now frames as quantum phenomena. Consider the accounts of contemporary indigenous cultures, where dreamers and shamans describe journeys to spirit worlds that operate outside ordinary time. The San people of southern Africa speak of the rain dance, a trance-induced state where healers encounter geometric patterns, grids, spirals, tunnels identical to those painted in Paleolithic caves. These visions, they say, are maps of a hidden reality, a dimension where all life is interconnected. Quantum physics, in its own way, points to a similar truth. At the subatomic level, particles communicate instantaneously across vast distances, as if space is an illusion. The cave's dream-inspired art might have been humanity's first attempt to depict this non-local reality, where separateness is an illusion and everything is woven into a single, vibrating web. The crossover between dreams and quantum strangeness doesn't stop at imagery. Both realms challenge our grasp of causality. In dreams, effects can precede causes. A scream might summon the danger that provoked it. Quantum experiments, too, show that observing a particle now can alter its past state, a phenomenon called retrocausality. The cave artists working in torchlit darkness might have experienced time as similarly malleable. Their paintings often layer generations of imagery, newer figures overlapping older ones, creating a palimpsest where past and present coexist. This layering could reflect a dreamlike perception of time as cyclical or fluid, a notion modern physics entertains in theories like the block universe, where past, present, and future are equally real and unchanging. Perhaps the most profound connection lies in the act of creation itself. When we dream, the brain constructs entire worlds from fragments of memory and imagination. Much like the quantum field generates particles from fluctuations in energy. The cave artists, dipping fingers into pigments, might have felt they weren't just painting but conjuring, bringing forth beings and symbols from a realm as intangible as the quantum foam. Their handprints pressed beside mammoths and stars could be signatures of this alchemy. Here I made the unseen scene. In the flickering light, with the cave's acoustics amplifying every breath, the line between dream and waking life would have blurred, allowing them to channel visions that science is still struggling to quantify. The caves, then, might be more than galleries of prehistoric art. They could be archives of humanity's oldest dreams, and in those dreams, whispers of a universe far stranger, far more connected than we ever dared to imagine. What if the flickering torchlight in those ancient caves did more than illuminate walls? What if it opened doors to other worlds? Some researchers suggest that the artists who painted these subterranean galleries weren't just depicting the animals they hunted but recording visions from altered states of consciousness, where the boundaries of reality stretched thin. In the depths of caves like France's Trois Freres, figures emerge half human, half beast, their forms shimmering between dimensions like shape-shifting entities. These hybrid beings, part stag, part man, or birds with serpentine tails, might not be mere mythology. They could be snapshots of realms accessed through trance, where the mind perceives realities beyond ordinary sight. Modern physics offers a startling parallel in the many worlds interpretation of quantum mechanics, which proposes that every decision spawns alternate universes, infinite versions of reality, branching like a cosmic tree. Just as these theories suggest unseen dimensions coexisting with our own, cave art might depict beings or landscapes from those parallel worlds. The geometric patterns common in Paleolithic art, zigzags, grids, nested curves, mirror the tunnels and portals described by modern-day psychonauts under the influence of entheogens or deep meditation. Indigenous shamans from the Amazon to Siberia report crossing thresholds into spirit worlds where time flows differently and entities convey cryptic knowledge. Could the caves have been ancient laboratories for dimensional travel, their artists serving as cartographers of the multiverse? The evidence isn't just symbolic, it's physiological. Brain scans of individuals in deep trance or psychedelic states show activity in the visual cortex producing patterns identical to those in cave art, fractals, spirals, and tessellating shapes. These aren't cultural artifacts but hardwired neurobiological responses, suggesting the artists were transcribing universal visions. In South Africa's caves, researchers found grindstones stained with residues of hallucinogenic plants, hinting at ritual practices designed to breach perceptual barriers. Meanwhile, quantum physicists grapple with the holographic principle, where our 3D reality might be a projection from a 2D surface, an idea that eerily mirrors how cave artists compressed cosmic truths onto flat stone. The most provocative overlap lies in the concept of non-locality. Quantum entanglement proves particles influence each other instantaneously across vast distances, defying classical physics. Similarly, cave art's recurring motifs like the handprints found from Argentina to Borneo suggest a shared consciousness, as if artists separated by millennia and continents tapped into the same informational field. Indigenous elders often speak of dream time or the spirit world as a place where past, present, and future merge, a description uncomfortably close to the block universe theory, where time is a fixed dimension and all moments exist simultaneously. Whether through drum-induced trance, plant medicines, or the cave's natural sensory deprivation, these artists may have accessed states that revealed reality's fluidity. Their paintings, then, aren't just art but postcards from the edge of existence, testaments that the universe has always been vaster, weirder, and more interconnected than our ordinary senses perceive. And if that's true, those ancient torchlit chambers weren't just shelters. They were telescopes not pointed at the stars, but into the depths of consciousness itself. Among the swirls and curves adorning ancient cave walls, some patterns stand out with an almost eerie precision, the kind of spirals that seem to grow organically, expanding in perfect proportion as they coil outward. These aren't just random flourishes. In caves like Spain's La Pasiega and France's Rouffignac, researchers have identified spirals that follow the Fibonacci sequence, a mathematical pattern where each number is the sum of the two preceding ones. This ratio, often called nature's secret code, appears everywhere from the arrangement of sunflower seeds to the spiral arms of galaxies. Yet here it is, etched into stone by hands that predate written language by tens of thousands of years. Take the famous Panel of the Horses in Lascaux. Among the charging herd, one horse's mane flows in a series of nested curves, each layer mirroring the Fibonacci progression. The spacing between these arcs matches the golden ratio, approximately 1.618, a proportion revered by artists and architects from the Parthenon to Da Vinci's Vitruvian Man. But how could Paleolithic artists, without formal mathematics, replicate a pattern so precise? The answer might lie not in calculation but observation. These artists lived intimately with nature, studying the curl of fern fronds, the twist of ram's horns, the unfurling of seashells, all structures that embody Fibonacci's sequence. Their art wasn't just imitation, it was an unconscious homage to the rhythms of the living world. The implications stretch far beyond aesthetics. In Indonesia's Sulawesi caves, hand stencils border spirals that echo the growth patterns of nautilus shells, their chambers expanding in Fibonacci perfection. Modern physics finds these same ratios in quantum spin networks, the fractal geometry of space-time, even the distribution of matter in the cosmos. It's as if the caves hold a visual language of creation itself, a bridge between the microscopic and the cosmic. What's truly humbling is the universality of this pattern. The same spirals appear in the rock art of Arizona's ancestral Pueblones, the carvings of Scotland's Picts, and the body art of Australia's Yolngu people. Cultures separated by continents and millennia all converged on this same geometric truth, not through shared knowledge, but through shared observation of a world built on mathematical harmony. The caves, then, might be humanity's first textbooks, teaching a lesson we're still learning, that the universe speaks in numbers and beauty is never accidental. The deep, resonant hum of a bullroarer spinning through the air, a simple flat piece of wood whirled on a cord, creates vibrations that seem to warp the very atmosphere around it. Used in rituals from Aboriginal Australia to ancient Europe, these instruments weren't just noisemakers. Their spinning motion, accelerating faster and faster until the sound becomes a visceral roar, bears an uncanny resemblance to the principles behind modern particle accelerators. In massive facilities like CERN, subatomic particles are propelled at near light speeds, colliding to reveal the universe's building blocks. Could ancient rituals involving spinning tools like bullroarers have been an intuitive nod to these same cosmic forces? Then there's the drum, perhaps humanity's oldest instrument. In shamanic traditions worldwide, rhythmic drumming serves as a gateway to altered states, its steady beats syncing with brainwaves to induce trance. But listen closer, and the parallels to particle physics grow eerie. The rapid, repetitive strikes of a drum mimic the pulsed energies used in cyclotrons, where particles are hurled in spiraling paths before smashing together. The Dogon people of Mali, for instance, used drumming rituals to symbolize the vibrations of creation, a concept uncomfortably close to string theory's assertion that reality is woven from tiny, oscillating filaments. Even the circular motion of drumsticks echoes the cyclic paths particles take in accelerators like the Large Hadron Collider. Perhaps the most striking connection lies in the intent behind these rituals. Ancient ceremonies often sought to harness invisible forces, summoning rain, healing the sick, or communing with ancestors. In a way, that's not so different from particle physicists probing the unseen fabric of reality. Both endeavors aim to manipulate energies beyond ordinary perception. The Su-Sun dance, where participants spin tethered to a central pole, mirrors the way particles are spun in synchrotrons. The whirling dervishes of Sufi tradition, lost in ecstatic rotation, evoke the dizzying orbits of quarks and leptons. Even the materials hold secrets. Many ritual objects were made from materials like quartz or magnetite minerals with piezoelectric or magnetic properties that interact subtly with energy fields. A bullroarer's wooden blade, when spun, generates infrasound frequencies capable of altering consciousness, not unlike how particle beams are tuned to specific resonances. The drums used in Siberian shamanism were often adorned with iron rings, creating electromagnetic disturbances as they moved, an accidental parallel to how accelerators use magnetic fields to steer particles. This isn't to suggest ancient cultures understood quantum mechanics, but their tools and rituals might have tapped into a visceral, symbolic truth about the universe's nature. That reality is built from motion, vibration, and collision. The cave's echoing chambers, filled with the thunder of drums and the whirl of bullroarers, could have been humanity's first particle labs, places where the unseen was made tangible through sound and movement. And if that's the case, then those rituals weren't just ceremonies. They were experiments conducted long before science had the words to describe what they were finding. Snakes slither across cave walls from France to Australia, their sinuous forms carved or painted with striking reverence. In the darkness of Chauvet Cave, a serpent coils beside a mammoth, its body etched with undulating precision. At Australia's Arnhem Land, rainbow serpents stretch across rock panels, their scales shimmering with symbolic power. These aren't just depictions of reptiles, they're embodiments of something far grander. Across cultures, serpents symbolize creation itself. From the Aboriginal Dreamtime's ancestral beings to the Norse world serpent Jörmungandr, whose body encircles the earth. But what if these ancient images hold a deeper secret, one that resonates with the very fabric of reality as modern physics understands it? Consider the serpent's shape, a continuous, flowing curve that seems to pulse with energy. In quantum physics, waveforms describe how particles behave as both matter and energy, their movements plotted as oscillating lines on a graph. These waveforms, with their peaks and troughs, mirror the rhythmic undulations of a snake in motion. Even space-time, warped by gravity, curves in ways that evoke a serpent's path. Think of Einstein's description of planetary orbits as objects rolling along the contours of a cosmic fabric. The serpent, then, might have been humanity's first intuitive sketch of these invisible forces, a way to depict energy's fluidity long before equations could capture it. The connection grows even more compelling when examining creation myths. The Hopi speak of a plumed serpent who shaped the world through vibration, while Hindu cosmology describes the serpent Ananta floating on the waters of chaos, its coils supporting the universe. These stories eerily parallel modern theories of quantum foam, where spacetime itself emerges from a seething, energetic void. The serpent's recurring role as a cosmic architect suggests ancient cultures recognized a truth physics now quantifies, that reality is woven from dynamic, wave-like energies. Perhaps the most striking parallel lies in the serpent's association with transformation. Shedding its skin, the snake becomes a universal symbol of renewal, a concept mirrored in quantum field theory, where particles constantly annihilate and reappear from the vacuum. In Egypt, the Ouroboros, a serpent eating its own tail, symbolized eternal cycles, much like the closed loops of string theory or the endless recycling of matter in the cosmos. Even the serpent's flickering tongue, sampling the air, finds an echo in quantum sensors detecting elusive particles. The caves, with their shadowy recesses, may have amplified this symbolism. A torch's flicker would have made painted serpents seem to writhe, their bodies alive with movement, an effect not unlike the probabilistic dance of subatomic particles, never static but always in flux. Whether by accident or insight, these ancient artists captured a truth that transcends time, that the universe isn't rigid but fluid, a great serpent forever in motion, weaving the world into being with every twist and turn. The flickering glow of torchlight didn't just illuminate the cave walls, it brought them to life. Step into the depths of Lascaux or Chauvet with a single flame, and something extraordinary happens. The animals seem to move. Shadows dance across the contours of painted bison, making their muscles twitch as if ready to charge. Horses gallop in the wavering light, their legs blurring into motion like frames of an ancient animation. This wasn't just accidental artistry, it was a deliberate mastery of light and perception, a way to make static images pulse with vitality. Early humans didn't just paint scenes, they engineered experiences, using fire's unstable glow to create the illusion of life millennia before the invention of cinema. Now hold that thought and leap forward to the quantum realm, where light itself behaves in ways that defy common sense. In modern physics, light exists as both particle and wave, a paradox known as wave-particle duality. Shoot photons through a slit, and they'll form an interference pattern, as if each particle is a wave overlapping with itself. Yet when observed, they collapse into discrete points, acting like solid bits of matter. This duality mirrors the cave artist's interplay of light and shadow. Just as torchlight blurred the lines between painted figures and the darkness around them, quantum mechanics reveals that reality isn't fixed but fluid, shifting depending on how and when we choose to look at it. The connection deepens when you consider how these ancient artists exploited the cave's natural acoustics. In places like Spain's Altamira, the most dynamic paintings are often found in chambers with the strongest echoes. A flickering torch near a painted stag might make it appear to move, while the sound of chanting reverberating off the walls could create an immersive, almost otherworldly experience. This multisensory approach, where visual movement and auditory vibration intertwine, finds a parallel in quantum experiments, where observation isn't passive but participatory. The very act of measuring a particle changes its behavior, just as the act of shining light on a cave painting transforms its meaning. What's truly mesmerizing is how universal this technique seems. In Indonesia's Maros Pangkep caves, hand stencils appear to pulse when illuminated by firelight, as if the hands themselves are pressing out from the stone. In North America, petroglyphs carved into curved rock faces create shifting illusions as sunlight moves across them. These effects aren't just artistic flair, they're evidence of a profound understanding of perception's malleability. Early humans grasped something essential: that reality isn't static but a dance of observation and interpretation. The caves then become more than galleries. They're early laboratories of consciousness, places where the boundary between seen and unseen, real and imagined, was deliberately blurred. Just as quantum physics forces us to confront the role of the observer in shaping reality, these ancient artists seem to have known that light isn't just a tool for seeing, but for creating. Every flickering torch, every carefully placed painting was a testament to a truth we're still unraveling: that the universe doesn't just exist, it performs. And we, whether holding a torch or a particle detector, are both audience and co-creators of the show. Hidden among the vivid animal figures and handprints on cave walls, a quieter revolution might have been unfolding, one that would shape the future of human thought. Tiny notches, dots arranged in grids, and sequences of parallel lines seem almost like afterthoughts compared to the dramatic bison and mammoths. But these abstract marks could be far more than decoration. Some researchers argue they represent humanity's first steps toward symbolic mathematics, a visual language for recording quantities, cycles, and even geometric relationships long before numbers existed as we know them. Take the Ashango bone discovered near the Congo River, a 20,000-year-old tool carved with a series of deliberate tally marks grouped in patterns. The notches aren't random. They cluster in sequences that suggest an understanding of prime numbers or lunar phases. Similarly, in caves like El Castillo in Spain, rows of dots repeat in intervals that mirror the days between moon phases or the seasonal return of migratory herds. These patterns hint at something profound. Early humans weren't just counting, they were encoding relationships, creating a bridge between observation and abstraction. The geometric precision of some cave symbols deepens the mystery. In Portugal's Escaural cave, intersecting lines form perfect right angles, while in France's Font de Gaume, zigzags repeat with mathematical regularity. These aren't the haphazard scratches of idle hands. They resemble the foundational elements of geometry, the same principles later formalized by Pythagoras and Euclid. One striking example comes from South Africa's Blombos Cave, where 73,000-year-old crosshatch designs on ochre fragments display symmetry so exact, researchers suggest they required planning and measurement. What's fascinating is how these symbols mirror the way mathematics emerged independently across cultures. The Sumerians used wedge-shaped cuneiform for accounting, the Maya tracked time with bar and dot numerals, and the Inca recorded vast datasets with knotted quipu strings. Cave art's abstract marks might belong to this same lineage, an early, universal impulse to translate the world's rhythms into symbols. Even the placement of these symbols holds clues. In some caves, they cluster near chambers with exceptional acoustics, as if the act of counting or measuring was tied to ritual, where sound and number intertwined. The leap from these markings to formal mathematics isn't as vast as it seems. A row of dots could evolve into numerals, a spiral could encode the golden ratio, and intersecting lines might later become the axes of a coordinate system. The caves, then, weren't just humanity's first art studios, they might have been our earliest classrooms, where the language of the cosmos was first sketched in charcoal and ochre. And if that's true, those cryptic symbols on the walls aren't just ancient graffiti, they're the first equations waiting millennia for us to decipher their meaning. Amid the meticulously painted bison and spirals, some cave walls bear markings that seem almost frantic clusters of lines scratched haphazardly, overlapping strokes that defy clear interpretation. At first glance, these chaotic scrawls appear random, as if the artist's hand moved without intention. But look deeper, and a fascinating possibility emerges. What if these seemingly disordered marks aren't mistakes, but deliberate explorations of chaos itself? In the caves of Pechmerle and La Marche, frenzied zigzags and tangled webs of pigment sprawl across stone, their energy starkly different from the careful renderings of animals nearby. These could be more than abstract doodles. They might mirror an ancient intuition about entropy, the natural tendency of systems to descend into disorder, a concept central to modern thermodynamics. Consider how thermodynamics describes the universe's inexorable slide toward chaos, energy dispersing, structures breaking down, yet within that chaos, hidden patterns persist. The same principle seems to pulse through these messy cave markings. In Spain's Cueva de la Vieja, a panel of red strokes looks like a storm of energy frozen in time, yet statistical analysis reveals the lines cluster in densities that follow mathematical distributions, much like the way gas molecules spread unpredictably but obey underlying physical laws. Even the apparent randomness of finger flutings, lines drawn by dragging fingers through soft cave clay, often repeat specific angles or rhythms, suggesting a subconscious grasp of chaos's hidden order. This duality, chaos-containing pattern, resonates across disciplines. Indigenous cultures worldwide describe creation emerging from primordial disorder, like the Maori's Tikor, the void brimming with potential. Similarly, thermodynamics teaches that entropy isn't pure destruction. It's the engine driving change, the reason stars burn and life evolves. The cave artists, surrounded by nature's untamed forces, might have sensed this paradox. Their chaotic markings could be meditations on balance, the interplay of randomness and rhythm that defines everything from weather to wildfire. The most compelling evidence lies in the cave's acoustics. In chambers where these disordered marks cluster, sound behaves unpredictably, echoes fracture into cascading whispers, mimicking entropy's dissipative effects. Modern chaos theory uses similar principles, where tiny variations in initial conditions create wildly divergent outcomes, like the butterfly effect. Perhaps ancient artists immersed in these echoing spaces, internalized the lesson that chaos and order aren't opposites but partners in an eternal dance. Their markings, then, aren't failures of control but celebrations of nature's untamed creativity, a reminder that even in apparent randomness, the universe hums with hidden structure. The moment an ancient artist pressed their palm against the cave wall, leaving behind a stenciled handprint in blown ochre, something profound occurred, not just an artistic act, but a transformation of the space itself. These caves weren't blank slates, they were living, echoing chambers where every stroke of pigment altered the environment irrevocably. The artist's presence didn't just record reality, it reshaped it, turning silent stone into a resonant gallery of meaning. This mirrors one of quantum physics' most unsettling truths, the observer effect, where the mere act of measuring a particle changes its behavior. In both cases, the witness becomes part of the story, bending reality by the very act of engaging with it. Consider how cave art often clusters in specific chambers, those with the best acoustics, the most dramatic rock formations, or the deepest darkness. The artists didn't just choose these spots randomly, they selected them because their presence there would have the greatest impact. In quantum experiments, the choice of how and where to observe a particle determines whether it behaves as a wave or a particle. The double-slit experiment famously shows that particles spread out like waves when unobserved but collapse into definite positions the moment a detector is introduced. Similarly, the cave's untouched walls existed in a kind of quantum superposition, a potential canvas for infinite possibilities until the artist's hand brought one of those possibilities into sharp relief. The parallels grow even stranger when you examine the rituals that might have surrounded these paintings. Shamans entering trance states to commune with spirits weren't passive observers. Their focused attention likely charged the space with intention, much like a quantum physicist's measurement device fixes a particle state. In both cases, consciousness plays an active role. The Aboriginal concept of dreaming illustrates this beautifully, the idea that the land is alive and responsive, shaped by the stories and attention of those who move through it. Modern physics suggests something eerily similar, that the universe isn't a static backdrop but a participatory phenomenon where observation and reality are inextricably linked. Even the materials used hint at this interplay. Ochre, the sacred pigment in many cave paintings, contains iron oxide, a mineral sensitive to magnetic fields. When applied to cave walls, these paintings might have subtly interacted with the Earth's geomagnetic fluctuations, creating a feedback loop between artist and environment. Quantum systems exhibit the same delicate sensitivity. The spin of an electron, for instance, aligns with magnetic fields in ways that alter its measurable properties. The cave, then, becomes a kind of macroscopic quantum lab, where human intervention leaves visible traces on the unseen fabric of the world. What's haunting is how this principle extends beyond the caves. Just as the observer effect implies that reality has no independent existence outside our interaction with it, cave art suggests that meaning isn't inherent, it's co-created. A bison painted on a wall isn't just a representation, it's a collaboration between the artist's vision, the rock's contours, and the flickering light that animates it. Quantum physics tells us particles have no definite properties until measured. Cave art shows us images have no fixed meaning until witnessed. Both reveal a universe that doesn't simply exist, it responds, adapting itself to the presence of those who dare to look. Polished to a glassy sheen by millennia of water and mineral deposits, some cave walls don't just absorb light, they throw it back, turning the stone into mirrors. In the flickering glow of a torch, these surfaces would have shimmered like dark pools, capturing not just reflections of the artists who stood before them, but something far more profound, the night sky. At sites like France's Grotte de la Vache, sections of the walls are so smooth they could have functioned as primitive observational tools, their concave curves subtly distorting and magnifying whatever was cast upon them. Imagine an ancient stargazer pressing close to the stone, angling a torch just so, and watching as the cave's ceiling suddenly becomes a canvas for the stars above, pinpoints of firelight mimicking constellations, their movements tracked over hours or seasons. These caves might have been humanity's first planetariums, where the cosmos wasn't just painted but actively studied. The concept isn't as far-fetched as it sounds. Indigenous cultures worldwide have long used natural reflective surfaces, still water, polished obsidian, even ice, to observe celestial events. The Maya, for instance, monitored Venus's cycles using obsidian mirrors, while Norse navigators relied on sunstones to locate the sun through clouds. In the caves, the principle could have been similar. A strategically placed torch near a curved, reflective wall might have projected the outside sky onto the interior, allowing early astronomers to note the shifting positions of stars or the moon's phases without braving the elements. The famous Panel of the Dots in Spain's El Castillo cave, where red pigment clusters align with solstice events, could even mark where these reflections were most accurate. A kind of prehistoric star chart etched in light rather than pigment. What's striking is how this aligns with the sacred roll caves held in many cultures. They weren't just shelters but liminal spaces, thresholds between worlds. If their walls could capture and amplify celestial light, they'd have been seen as portals to the heavens, places where the boundary between earth and sky dissolved. In Romania's Cusiulat cave, a painted panel of horses faces a naturally reflective wall, as if the animals are galloping toward their own celestial doubles. The effect would have been uncanny, real and reflected images merging, blurring the line between the tangible and the ethereal. Modern astrophysics lends unexpected support to this idea. Researchers studying light behavior in confined spaces note that even rough surfaces can create caustic networks, complex patterns of reflected or refracted light that amplify specific wavelengths. In a cave's torchlit darkness, these effects would have been magnified, turning random flickers into controlled projections. The cave's acoustics add another layer. Chanting or drumming near these reflective walls could have made the projections seem to pulse in time, as if the stars themselves were alive and responsive. This transforms how we see the art. Those painted dots and lines might not just represent stars, they could be records of observations made via these stone mirrors, a blend of art and science encoded in ochre. The caves, then, weren't passive galleries but dynamic instruments, their walls functioning like the mirrored telescopes Galileo would later use to revolutionize astronomy. And if that's true, those ancient handprints beside the paintings take on new meaning. They're not just signatures, but the marks of humanity's first astronomers, reaching through the stone to touch the sky. At first glance, the gap between ancient cave paintings and modern particle physics seems unbridgeable, one born of torchlit intuition, the other forged in the sterile glow of supercolliders. But strip away the trappings of time and technology, and a startling truth emerges. Both are acts of translation. The cave artist crouching in the damp darkness, grinding ochre into pigment, and the physicist hunched over a detector, tracing subatomic collisions on a screen, are engaged in the same essential quest. They're deciphering the universe's hidden language, one through symbol and story, the other through equation and experiment. Consider the tools of each discipline. The artist's palette charcoal, iron-rich clays, crushed minerals transforms raw earth into visions of bison and stars. The physicist's tools, particle accelerators, cloud chambers, supercomputers turn energy into data, revealing quarks and neutrinos. Both are alchemists converting the mundane into the revelatory. The Lascaux painter who layered pigments to create the illusion of movement wasn't so different from a quantum physicist graphing the probabilistic dance of electrons. Both manipulate their mediums to make the invisible visible, whether it's the spirit of a galloping horse or the waveform of a photon. This kinship extends to their methods. Cave art wasn't haphazard. It followed rules-specific animals in certain chambers, symbols repeated with ritual precision. Similarly, particle physics operates within the rigid framework of the scientific method, testing hypotheses against observable reality. Yet both leave room for the inexplicable. The shaman interpreting visions from a trance and the theorist wrestling with quantum entanglement's paradoxes share a common struggle: how to articulate truths that defy ordinary perception. The cave's hybrid creatures, part human, part beast, find their counterpart in physics' wave-particle duality, where matter resists singular definition. What unites them most profoundly is their shared reverence for pattern. The artist who painted a spiral in Newgrange sensed the same cosmic order that compels physicists to search for unified field theory. One saw it in the curl of a fern or the whirl of a galaxy. The other expresses it as E equals mc2, or the Fibonacci sequence's recurrence in quantum spin networks. These patterns aren't arbitrary, they're the universe whispering its secrets in a code that transcends time. The difference lies not in purpose but in perspective. Where science seeks to demystify, ancient art often embraced mystery, using ambiguity as a gateway to the sacred. A bison painted in flickering torchlight isn't just an animal, it's a vessel for awe, a reminder of forces beyond human control. Physics, for all its rigor, still grapples with the same awe when confronting black holes or dark matter phenomena that humble even the most brilliant minds. Perhaps this is why the dialogue between cave art and particle physics feels so urgent today. As science probes ever deeper into the quantum foam, it encounters a reality that feels increasingly mythic, where particles teleport, time bends, and empty space seethes with potential. These discoveries don't diminish the cave painter's intuition, they validate it. The spirals on those ancient walls weren't primitive doodles. They were the first equations, written in a language of pigment and stone, waiting for us to rediscover their wisdom. Art and science, it turns out, aren't opposites. They're twin lenses focusing on the same dazzling, ineffable truth. In a studio high above Manhattan's bustling streets, artist Julie Meritou stands before a massive canvas, her brush tracing swirling, labyrinthine patterns that seem to vibrate with hidden energy. Her work, celebrated in museums worldwide, draws direct inspiration from the spirals and handprints of Paleolithic caves, reimagining them through the lens of quantum physics and urban chaos. There's a rhythm in those ancient marks, she explains, a pulse that mirrors how subatomic particles dance in colliders. Meritou isn't alone in this fusion of epochs. Across disciplines, creators and researchers are turning to cave art not as relics, but as living blueprints, discovering that 30,000-year-old symbols hold startling relevance in the age of string theory and AI. Take physicist Marcelo Gleiser, who collaborates with indigenous artists to map quantum vacuum fluctuations using designs inspired by Aboriginal dot paintings and European cave grids. His team's visualizations, displayed at CERN public galleries, reveal how ancient motifs can articulate cutting-edge concepts like zero-point energy. The dots in cave art aren't just decoration, Gleiser notes. They're topological maps of how energy condenses into matter, a language our equations are only now decoding. Similarly, composer John Luther Adams translates the acoustic properties of caves like France's Font de Gaume into orchestral works, where musicians mimic the reverberations of prehistoric chambers, making audiences feel the primal connection between sound, stone, and spacetime. Meanwhile, in the digital realm, new media artist Rafik Anadol employs machine learning to animate Lascaux's animal figures using real-time data from particle detectors. His installations, which project cave paintings that morph in response to cosmic rays, suggest a dialogue between Paleolithic intuition and artificial intelligence. These artists sensed the universe's interconnectivity, Anadol reflects. Now we're giving their visions new forms of expression, algorithmic, responsive, alive. Even fashion designers like Iris van Herpen weave cave art's fractal patterns into 3D printed garments, their undulating silhouettes mirroring both quantum foam and the sinuous curves of Chauvet's horses. The dialogue flows both ways. Archaeologists now use tools from quantum mechanics, like neutron tomography, to uncover hidden layers of cave paintings without damaging them. In Spain's Axara cave, this technology revealed previously invisible etchings of bison superimposed over older handprints, a palimpsest echoing the superposition of quantum states. It's poetic, says researcher Olivia Rivero. The same principle that lets electrons exist in multiple places at once is helping us see how ancient artists revisited and reimagined their own work across generations. Perhaps the most poignant collaborations emerge in indigenous communities, where elders and astrophysicists co-create Planetarium shows blending ancestral star lore with Hubble imagery. At Chile's Olma Observatory, Atacamino elders point out how their people's rock engravings of llamas mirror the dark constellations they've tracked for millennia, patterns Western astronomy long overlooked. The caves were our first observatories, shares elder Vilma Tabillo. Now scientists realize those old stories hold data about supernovas our ancestors witnessed. This renaissance isn't about romanticizing the past, it's about recognizing that the human drive to map the cosmos transcends time. When light artist Tatsuo Miyajima installs LED counters in caves, their flickering numbers counting down alongside prehistoric dots, or when quantum biologists study how cave pigments interact with biophotons in the human eye, they're continuing a conversation begun by torchlight. The caves whispered first, we're finally learning how to reply. Every stroke of ochre on these ancient walls is a whisper from the past, but with each passing year, those whispers grow fainter. The very act of breathing near the caves of Lascaux or Altamira introduces moisture that can degrade pigments laid down over 15,000 years ago. A single misplaced touch, a flicker of artificial light, even the microbial life carried in on visitors' shoes, these seemingly small intrusions can erase irreplaceable fragments of human history. The ethical dilemma is profound. How do we balance the hunger for knowledge with the imperative to preserve? These caves aren't just galleries, they're time capsules holding secrets that could rewrite our understanding of human cognition, early astronomy, and perhaps even the fundamental nature of reality itself. The stakes became tragically clear in Lascaux's green sickness outbreak in the 1960s, when algae blooms triggered by tourist exhalations forced the cave's permanent closure to the public. Today, even researchers face stringent restrictions, limited access hours, specialized clothing, and airlock systems to minimize contamination. Similar measures protect Chauvet Cave, where a single researcher's annual visit might last mere hours, conducted under the watchful gaze of humidity sensors and thermal cameras. This isn't overcaution, it's necessity. Recent laser scans of Spain's El Castillo cave revealed previously invisible markings beneath layers of calcite, delicate dot clusters that could be lunar calendars older than any known writing. If damaged before documentation, such discoveries vanish forever. Yet preservation isn't just about physical protection, it's about cultural respect. Many decorated caves hold sacred significance for indigenous communities. In Australia's Arnhem Land, Aboriginal elders work with archaeologists to document rock art using non-invasive 3D imaging, ensuring ancestral knowledge isn't extracted but collaboratively interpreted. These paintings aren't just pictures, explains Gagaju elder Big Bill Niji. Their lore, story, connection to country. When European researchers initially dismissed Aboriginal astronomical interpretations of cave symbols as myth, they overlooked sophisticated celestial knowledge, like the Wardaman people's understanding of variable stars encoded in rock art millennia before telescopes confirmed their existence. The scientific potential locked in these caves demands innovative solutions. In France's Pechmerle, researchers deploy muon tomography, a cosmic ray imaging technique borrowed from particle physics, to map chambers too fragile for human entry. Spanish conservators developed biopasting, using bacteria to gently dissolve mineral crusts obscuring paintings without harming original pigments. Meanwhile, projects like the Bradshaw Foundation's virtual cave tours allow global access without physical intrusion, preserving both art and the silent, shadowed atmospheres that shaped their creation. What's ultimately at stake transcends archaeology or physics. These caves are mirrors reflecting humanity's first attempts to comprehend the cosmos, a dialogue between intuition and observation that continues today in quantum labs and space telescopes. When a 4,000-year-old Siberian petroglyph of a supernova matches modern astrophysical records, or when a Paleolithic dot grid mirrors a quantum probability matrix, we're witnessing not coincidence but continuity. Each preserved marking is a thread in a tapestry stretching from torchlit caverns to particle colliders, reminding us that curiosity, and the responsibility it carries, is our species' oldest tradition. The challenge now is to listen without interrupting, to study without erasing. As laser scanners hum and AI reconstructs faded pigments atom by atom, we're learning to read these ancient walls without touching them, to let the caves speak on their own terms. In doing so, we honor both the hands that painted them and the generations yet unborn who deserve to stand in their glow, torchlight flickering across the same timeless questions. Deep beneath dense jungles or buried under shifting desert sands, countless caves remain untouched by modern hands, their walls likely adorned with art we've yet to see. With only a fraction of the world's caves fully explored, the potential for discoveries is staggering. Emerging technologies like LiDAR, light detection and ranging, are already peeling back layers of vegetation to reveal hidden entrances in places like Mexico's Yucatan Peninsula, where recent scans exposed a vast subterranean network that Mayans once used for celestial rituals. Imagine what similar tools could uncover in the uncharted caves of the Congo Basin or the Himalayas, where ancient artists might have left their own celestial blueprints. Artificial intelligence adds another dimension to this hunt. Machine learning algorithms trained on known cave art patterns can now scan drone footage or ground-penetrating radar data, flagging geological formations that likely contain undiscovered chambers. In Portugal, AI recently identified subtle mineral stains on satellite images that led archaeologists to a cave sealed for millennia inside. They found handprints arranged in a spiral mirroring the Fibonacci sequence. As these technologies grow more sophisticated, they could uncover sites where art encodes advanced astronomical knowledge, like lunar calendars predating Stonehenge or star maps tracking supernovas visible only to ancient eyes. The most tantalizing possibilities lie in caves that might bridge cultural divides. Siberia's Denisova Cave, already famous for revealing a previously unknown human species, could hold art connecting Paleolithic European and Asian traditions. Similarly, underwater caves off the coast of Indonesia, now accessible with submersible drones, might preserve art from early seafarers who carried symbolic knowledge across continents. Each new discovery could rewrite the timeline of human cognition, showing how widespread and ancient our fascination with cosmic patterns truly was. Beyond imagery, future finds might include artifacts that reveal how these artists worked. A paint palette left in a French cave in 2019 contained traces of manganese dioxide mixed with animal fat, a recipe later used by Renaissance masters. Similar tools, if found alongside astronomical markings, could prove these pigments were deliberately formulated to reflect specific wavelengths of light, turning cave walls into primitive observatory screens. Even the positioning of newly discovered art relative to cave acoustics might show intentional design, where certain symbols were placed to amplify ritual chants about celestial events. The greatest revelation might come from caves that challenge our assumptions entirely. What if a site is found where animals are painted alongside geometric shapes resembling quantum diagrams, or where human figures are depicted with features suggesting an understanding of microscopic life? In Australia's Northern Territory, a recently discovered rock shelter shows kangaroos painted with internal organs visible, as if the artist possessed anatomical knowledge. Future caves could hold similar surprises, blending the cosmic and the biological in ways that force us to reconsider the origins of scientific thought. Every undiscovered cave is a locked archive, its walls potentially holding answers to questions we've only begun to ask. As technology lifts the veil on these hidden galleries, we may find that our ancestors' grasp of the universe's secrets was far deeper and far stranger than we ever imagined. The next great leap in understanding human history might not come from a lab or a telescope, but from a flickering light illuminating paintings untouched for 40,000 years, waiting to speak across the ages. The haunting beauty of cave paintings lies not just in their artistry, but in the mysteries they leave unresolved. When we see dots that mirror star clusters or spirals resembling galactic formations, it's tempting to believe ancient artists possessed secret cosmic wisdom. But before we embrace this idea entirely, it's crucial to separate compelling connections from coincidental overlaps, to weigh what we can prove against what we might wish to be true. Take the celestial alignments. In Spain's El Castillo cave, clusters of red dots match the Pleiades star group with uncanny precision, and solstice sunlight still illuminates specific symbols just as it would have millennia ago. These aren't vague resemblances, they're demonstrable correlations backed by archaeoastronomers who have mapped cave art against prehistoric skies. Similarly, the acoustic properties of painted chambers where echoes amplify ritual chants reveal deliberate choices, not random chants. When a cave's most resonant spots consistently align with its most sacred art, we're seeing evidence of intentional design, yet not every pattern holds up to scrutiny. The famed quantum zigzags of Pechmerle might resemble Feynman diagrams to a modern eye, but without contextual clues. Like accompanying symbols or cultural records, they could just as easily represent lightning or rivers. Pareidolia, our brain's tendency to find familiar shapes in randomness, plays tricks here. A bison surrounded by dots might feel like a particle diagram, but it could simply depict raindrops or wounds. Even the Fibonacci spirals, while mathematically elegant, emerge naturally in many organic forms, from seashells to fern fronds. Without explicit cultural testimony, these parallels remain provocative but unproven. The strongest counterarguments come from anthropology. Many indigenous cultures today maintain unbroken traditions tied to their ancestral rock art. When asked, their elders rarely describe paintings as encoded physics lessons. Instead, they speak of creation stories, hunting magic, or spiritual visions. The Walpiri people of Australia, for instance, interpret dot clusters as ancestral footprints, not star maps. If cave artists truly aim to preserve cosmic secrets, wouldn't that knowledge have survived in oral traditions? That said, absence of evidence isn't evidence of absence. Oral histories fragment over millennia, and Western researchers have often dismissed indigenous interpretations as myth rather than metaphorical science. The Dogon people of Mali, for example, were long mocked for their detailed knowledge of Sirius's invisible companion star until telescopes confirmed its existence. Could some cave art encode similarly sophisticated observations, misunderstood because we've lost the key to their symbolism? The most balanced view acknowledges both possibilities. Some patterns, like solstice markers or lunar phase sequences, are too precise to dismiss. Others may reflect universal human experiences rather than specific knowledge. Spirals could symbolize life's cyclical nature rather than gravitational waves. Handprints might signify presence, not quantum observation. The truth likely lies in between a blend of practical astronomy, spiritual intuition, and artistic expression that resonated across generations. What's undeniable is this: whether by accident or insight, these ancient artists captured truths about the universe that science would take millennia to formalize. Their work invites us to marvel not just at their world, but at the enduring human drive to make sense of the cosmos one stroke of pigment at a time. Next time you visit a museum or hike past ancient rock carvings, try something different. Slow down and really look. That cluster of dots above a bison's back. It might not just be decoration. Those zigzags framing a human figure, they could be more than random scratches. Hidden in plain sight, local rock art might hold clues to the same cosmic mysteries we've been exploring. You don't need to be an archaeologist to start noticing these patterns. In fact, some of the most groundbreaking discoveries in cave art have come from everyday observers who simply paid attention. Take the work of amateur explorer Marc Azema, who spent years studying the flickering torchlight effects in French caves. His realization that overlapping animal legs created the illusion of movement, an early form of animation, rewrote our understanding of Paleolithic artistry. Or consider the Aboriginal elders in Australia's Kimberley region, who recognized that certain Wandjina figures weren't just spirits but representations of celestial beings linked to specific stars. These breakthroughs didn't come from high-tech labs but from patient, curious observation. You can join this detective work right where you are. Many museums now feature 3D scans of cave art, allowing you to rotate and zoom in on details that might reveal hidden patterns. Look for repeating motifs, grids that resemble quantum lattices, spirals echoing galactic arms, or dot clusters that align with solstice events. Even modern indigenous art often carries forward these ancient symbols. A Navajo weaving's geometric designs or a Maori tattoo's curves might encode similar cosmic principles. Better yet, get hands-on with citizen science initiatives like the Global Rock Art Database, where volunteers help catalog and analyze petroglyphs from around the world. Recent crowdsourced discoveries include a petroglyph in Colorado that tracks the 18.6-year lunar cycle and a Spanish cave's handprint array that aligns with seismic activity patterns. Your backyard might hold undiscovered connections. An overlooked boulder carving could be a star map, or a local cliff painting might mirror the fractal branching of lightning. The key is to approach these artworks with fresh eyes. Instead of seeing just a deer or a spiral, ask, could this represent something larger? Does its placement hint at astronomical events? Are there sound resonances nearby that might have ritual significance? Bring a notebook, sketch what you see, and compare it to known cosmic symbols. You might not crack an ancient code overnight, but you'll start seeing the world and humanity's place in it with new depth. After all, those ancient artists weren't creating for museums or textbooks. They were leaving messages about the stars, the land, the invisible forces shaping their lives. And now, millennia later, their work is still speaking. The real question is, are we listening? As we stand at the intersection of ancient art and modern physics, one thing becomes clear: humanity's quest to understand the universe is timeless. Those early artists crouching in torchlit caves and today's physicists hunched over quantum detectors are united by the same fundamental urge to decode the hidden patterns of existence. The ochre spirals on cave walls and the equations describing black holes might seem worlds apart, but they're both attempts to translate the cosmos into a language we can grasp. It's humbling to realize that 40,000 years ago, with no telescopes or microscopes, humans were already mapping the same celestial rhythms and geometric truths we now study with billion-dollar colliders. This connection isn't just poetic, it's practical. Indigenous astronomers tracking solstices with rock carvings were doing the same work as modern astrophysicists calibrating satellite arrays. The difference lies in tools, not intent. When a shaman painted dots mirroring the Pleiades or a physicist graphs the probability cloud of an electron, both are creating models to navigate the unknown. The caves were humanity's first laboratories, where intuition and observation collided to reveal truths about time, light, and interconnectedness, truths we're still unpacking today. What does this mean for us? It's an invitation to see curiosity as our shared inheritance. The next time you stare at a starry sky or run your fingers over ancient petroglyphs, you're not just observing, you're participating in a tradition that spans millennia. Those early artists left messages in pigment and stone. Today, we leave them in data and light, but the central question remains unchanged. How does this universe work, and where do we fit within it? So here's where you come in. Have you ever noticed a pattern in nature, a fractal fern, a spiral shell, that reminded you of something cosmic? Maybe you've stood in a cave or beneath a meteor shower and felt that eerie sense of connection, like you're touching something far older and wiser than yourself. That's the thread we've been following all along. Drop your experiences in the comments, because this conversation isn't just about the past or the future. It's about right now and the stories we'll leave for those who come after us. If this journey through time and science sparked something in you, don't let it end here. Hit subscribe to join us as we keep exploring the mysteries that bind art, history, and the cosmos. From the quantum quirks hiding in Neolithic symbols to the undiscovered caves that might rewrite our story, there's so much more to uncover. The universe has been whispering its secrets for millennia. Together, let's see what